Hello, everyone. My name is Atul Bhaskaran, and I took AP Stats as a freshman in the 2024-2025 school year. And today I will be talking about chi-square tests and how we can identify which test to use based on a given prompt. Here's the chi-square distribution. It's skewed right. And what is the chi-square distribution? The chi-square distribution is a skewed right distribution used for inference and significance tests. For this curriculum, you will never be asked to find a chi-square confidence interval. There are three different types of chi-square tests. Chi-square goodness of fit test, chi-square test for homogeneity, and chi-square test for independence/association. The first one we will be looking at is the chi-square goodness of fit test. Now this test has one sample and one variable/category. For one sample, the group you are examining has come from a sample, not multiple. So just one group we are selecting. And this is a big tip that helps me. In a given prompt, look for words such as a random sample or one random sample. And also, the other type of chi-square test that has one sample is independence/association. So make sure you can be able to distinguish the two. And next up is one variable/category. Examples of like a variable would be blood type, M&M colors, or yes or no questions. The prompt will only mention one category/variable if dealing with a goodness of fit test or homogeneity, which we will get into later. Now I'll go through an example prompt right now. The Human Resources Department of a very large corporation, more than 20,000 employees, suspects that people are more likely to call in sick on Monday or Friday, so they can take a long weekend. They took a random sample of 850 sick day reports from the past few years and determined the day of the week for each report. Here are the results. Do the data provide convincing evidence that sick day calls are not evenly distributed through the week? Justify your answer with appropriate statistical evidence. Now for the next page, I just annotated that example prompt to make sure you can really see how this is a goodness of fit test. So, the Human Resource Department suspects that people are more likely to call in sick on Monday or Friday. That is technically the category we are examining because that's they suspect this, so they are more likely. That is the category, and I told you A or 1 would be on here because they took a random sample of 850 sick day reports. Also, it can be kind of confusing because some prompts are tricky and they try to trick you, so make sure you look after the word a. And since it only says one a sample of 850 sick day reports, we can be sure that's one sample. So since we are given one sample in one category, we will use a good chi-squared goodness of fit test. Now the next type of chi-square test is a chi-square test for homogeneity. Now this test has two or more samples. This is the only test that we will go through that has two or more samples. Chi-square test for goodness of fit has one sample, and so does chi-square test for independence/association. So this test contains multiple samples from similar or different groups. I'll put some examples down here, like 187 males and 313 females were surveyed, or another example would be like 217 immigrants and 404 citizens were sampled. You can clearly see how these are two different groups being sampled because there's a different number. And yeah, and this is the same as a goodness of fit test since there's one variable being what do I say? One variable. Oh, sorry. There's one variable being implemented. So the same amount of variables for a goodness of fit test. Example, blood type, M&M colors, what I went through above. So here's another example prompt that we'll go through. A bank wants to determine which age groups among its customers are using their online banking services. They select a simple random sample of customers from 4 age groups and ask each person if they do most of their banking online or at their local branch bank. Here are the results. Perform the appropriate statistical test to determine if there is a difference in the banking preferences of these 4 age groups. Here's my annotated prompt, and basically what I did to mark up to make sure you realize that this is a test for homogeneity, sorry. Now, a bank wants to determine which age groups. So we will probably get just from this small excerpt, we can determine there are multiple age groups we will be sampling from. So that's pretty much a clear giveaway, but we can keep reading and we figure out they select a simple random sample of customers from 4 age groups. So this is 4 different samples. Now, some words like a or one can be kind of confusing here, like I said before, because they select a simple random sample of customers from 4 age groups. So even though it says A, there are 4 different samples, so you have to make sure to read ahead. And the variable we are testing is they ask each person if they do most of their banking online or at their local branch bank. So since we are giving 2 or more samples, which is 4 in this case, in one variable, we will use a chi-square test for homogeneity. And the last chi-square test we will be looking at is a chi-square test for independence/association. This test has one sample, which is the same amount as a goodness of fit test. And as I said before, it comes from a sample, not multiple. And in a given problem, look at a random sample or one random sample. And also a chi-square goodness of fit test has one sample, as I said before. But this is what's different about a test for independence/association. There are 2 variables/categories. So from one sample, we will be implementing 2 or more variables. In the same examples, like yes or no questions, blood type, blah, blah, blah. Here's an example prompt. I'll scroll down. A person studying fathers' involvement in their children's education interviews a simple random sample of fathers of school-age children. One question concerns regularly scheduled parent-teacher conferences. Here is a two-way table of the result. Based on your graphical analysis, discuss the relationship between family type and how often fathers attended parent-teacher conferences. Support your conclusion with the appropriate statistical test. Now, it says we see the word A here, and this is a good example on where we can use A to determine if it is a chi-square goodness of fit test or a chi-squared independence/association test. So they interview a simple random sample of fathers. So they interview one simple random sample of fathers. Now, if you go down, we can see the variables that are being implemented. So based on your graphical analysis, discuss the relationship between family type and how often fathers attended parent-teacher conferences. So we are given 2 distinct variables for this test. Now, another thing I would like to point out is it says discuss the relationship between. Relationship, the word can be interchangeable with association. So since this is called a chi-square test for association/independence, we can pretty much say that this is a chi-square test for association because relationship and association have basically the same meaning. So since we are given 2 variables, a simple random sample, and a word such as relationship, which can go hand in hand with association, we can use a chi-square test for association/independence. Now that we are done going over all 3 of the chi-square tests, here's what I tips from me on how that helped me on the AP Stats exam and throughout the curriculum implement the differences between all 3 chi-square tests. Now, how do I spot the difference between different chi-square tests? In question prompts, look for words like a random sample or one random sample, which I've said before. This is a really helpful tip that has helped me ace all my exams on chi-square tests in the AP exam. This will narrow down your options to 1 or 2, or a chi-square test for goodness of fit and a chi-square test for association/independence. If given a table, which we have seen in, I think, all three examples, look for two or more rows, or one row. One row means goodness of fit test, while two or more rows means a test for association/independence. If not given a table, it should be pretty easy to spot two variables compared to one, because it will give you words such as relationship between, which is association between, those can be hand in hand, and it will say between variable 1 and variable 2. Now, anything with two or more samples, this is automatically chi-squared test for homogeneity. It should be pretty easy to see if it says a simple random sample from 4 age groups, as we saw in the example above, or 187 males were surveyed and 313 females were surveyed. That's two different groups. So that's automatically chi-squared test for homogeneity. So those are my tips on how to figure out the difference. Now let's use these tips for some example prompts. Here's prompt number 1. In the study of the television viewing habits of children, a developmental psychologist selects a random sample of 300 first graders, 100 boys, and 200 girls. Each child is asked which of the following TV programs they like best: The Lone Ranger, Sesame Street, or The Simpsons. Results are shown in the contingency table or 2A table below. Do the boys' preferences for these TV programs differ significantly from the girls' preferences? Use a 0.05 level of significance. I'll give you a second to pause and figure out the answer. All right, the answer to prompt number 1 is we will use a chi-square test for homogeneity. The reason we use this is in the first sentence, it already says we'll select a random sample of 300 first graders, 100 boys, and 200 girls. That is two different groups we are sampling from. So without even looking at anything else, we can tell this is a chi-square test for homogeneity. But just to make sure, each child is asked which of the following TV programs they like best. That is the variable we are putting into play. So two samples, one variable. That means we will use a chi-square test for homogeneity. Now prompt number 2. Hold on, I'll move this. Is gender independent of education level? A random sample of 395 people were surveyed, and each person was asked to report the highest education level they obtained. The data that resulted from the survey are summarized in the following table. Are gender and education level dependent at 5% level of significance? In other words, given the data collected above, is there a relationship between the gender of an individual and the level of education that they have obtained? I'll give you a second to think about the answer so you can pause. All right, the answer to prompt number 2 is a chi-square test for association/independence. So, the second sentence, it says a random sample of 395 people was surveyed. So that is one sample, a random sample that I've been keep on pointing out. So that is one sample. We already knocked off homogeneity, so we have two options now: association/independence and goodness of fit test. Now let's look at our two-way table. This is another giveaway, but this is a giveaway for why this is a test for association/independence. There are multiple rows. There's 2 rows. That's 2 or more rows. So this is association/independence, and goodness of fit test gets knocked off. Now another giveaway, our gender, one variable, and education level, which is another variable, dependent at a 5% level of significance. That is 2 variables. And another thing I'd like to point out that I forgot to highlight here, is there a relationship? Relationship is another word for association, so we will use a chi-square test for association/independence. Prompt number 3. Acme Toy Company prints baseball cards. The company claims that 30% of the cards are rookies, 60% veterans, but not all-stars, and 10% are veteran all-stars. Suppose a random sample of 100 cards has 50 rookies, 45 veterans, and 5 all-stars. Is this result consistent with Acme's claim? Use 0.05 level of significance. I'll give you a second to think about the answer so you can pause. All right, the answer to problem number 3 is a chi-squared goodness of fit test. This one is a very short prompt, but there's a lot to take away from it. So, suppose a random sample of 100 cards has 50 rookies, 45 veterans, and 5 all-stars. This is pretty tricky because they give you a lot of numbers, and it makes you think, oh, so each of these numbers are different groups that you were sampling from, so it's obviously homogeneity. But it's not, because the random sample of 100 cards contains the 50 rookie cards, 45, and 5 all-stars. So inside of the one sample, there are this many cards. So this is actually one sample, and then the variable we are testing is the result consistent or the same as Acme's claim? So that is one variable, one sample, which leads us to use a chi-squared goodness of fit test. Now we have 2 more examples. The operations manager of a company that manufactures tires wants to determine whether there are any differences in the quality of work among the 3 daily shifts. She randomly selects 496 tires and carefully inspects them. Each tire is classified as perfect, satisfactory, or defective. In the shift that produced, it is also recorded. The 2 categorical variables of interest are the shift and condition of the tire produced. The data can be summarized by the accompanying to a table. Does the data provide sufficient evidence at the 5% significance level to infer that there are differences in quality among the 3 shifts? I'll give you a second to think about it. All right, the answer to problem number 4 is a chi-square test for association/independence. So, in the prompt, we are given one sample. I'll move this again. She randomly selects 496 tires and carefully inspects them. We are given no different groups, just that one sample, 496 tires. That is one sample. We knock off homogeneity right there and then. And in the highlighted in red, this, you don't even have to really think about 2 variables, because this prompt technically just gives it to you. It says the 2 categorical variables of interest are the shift and condition of the tire produced. So 2 variables, shift and condition. But it literally says the 2 categorical variables of interest. So we know that's 2 variables. I said down here, literally tells you that there are 2 variables. So one sample, 2 variables. What does that lead us to believe? We will use a chi-square test for association/independence. Now here's the last practice prompt. A university admissions officer was concerned that males and females were accepted at different rates into the 4 different schools: business, engineering, liberal arts, and science at her university. She collected the following data on the acceptance of 1,200 males and 800 females who applied to the university. Are males and females distributed equally among the various schools? I'll give you a second to think about the answer. All right, the answer to prompt number 5 is a chi-square test for homogeneity. The reason it is chi-square test for homogeneity, the last sentence of the prompt, she collected the following data on the acceptance of 1,200 males, that is group number 1, and group number 2 is 800 females who applied to the university. These are 2 different groups. Without even looking at anything else, we know this is a chi-square test for homogeneity. But the variable we're testing is, are males and females distributed equally among the various schools? So, 2 samples, 1 variable. The answer is chi-square test for homogeneity. Now, thank you so much for watching. I hope this video helped you distinguish the differences between 3 different types of chi-square tests, and hopefully this helped again. Here's the chi-square distribution again. Thank you so much for watching.